What is a pointer? A pointer is a variable that holds a memory address. Usually this address is for another variable of the same type as the pointer. For example, if the pointer is pointing to an integer variable, then it's called an integer pointer. I want you to understand that a pointer is just a variable in memory. It will take some memory space for its own, but the value inside it is going to be a memory address of another location in memory. How do you declare a pointer in C and C++? So as you can see in this example, I'm right now declaring an integer pointer. So P is a pointer to integer. You can read this from right to left, by the way, or you can say integer pointer P. Unfortunately, the C++ language did not introduce a new keyword for pointer, so they just use the asterisks. There are multiple styles for how you declare a pointer. One such style is to say the type followed by the star immediately, space the variable name. This style is actually encouraged by Bjarne Stroustrup, the inventor of C++, or you can declare it this way, integer space star P. They're the same for the compiler. In fact, if you put as many spaces as you want, the compiler is smart enough to understand that this is a pointer. This is just mainly for us to understand pointers and to stick to guidelines and coding conventions. I just encourage you to be consistent. And this is the third form that I just mentioned, which is you can do it this way. Pick the one that you feel most comfortable with and start getting used to a certain style. Okay, so now when we're declaring a pointer like this, it's considered to be uninitialized. This pointer is actually pointing to somewhere in memory. It could be inside the operating system code, could be inside some guarded memory, some place that you're not supposed to access. By accessing an initialized pointer, you might run into cases like crashing your program, causing some weird behavior to the system. So be aware of that. Modern compilers will warn you about this. So just keep in mind that you always have to initialize your pointers before you use them. So how do we make this pointer point to somewhere in memory? We use the address of operator. So we assign addresses to pointers by using the address of operator. Okay, so in this example, I'm going to show you how we declare an integer and a pointer to integer. If you remember from previous lectures, we said that the integer type takes up 4 bytes if we're on a 32-bit or a 64-bit system. The size on Windows is 4 bytes. The pointer, though, is usually going to be 4 bytes if it's 32-bit, or if you're on a 64-bit system, then it's going to be 8 bytes. And the reason for that is a pointer holds the memory address. In this example, I'm going to use 32-bit. An integer A is going to take up 4 bytes, for example, from 8001 to 8004. If we assign 14 to it, it's just going to hold the value here in this memory. Again, remember that this is in binary format, not in decimal. Decimal is just for us to understand. If we say print the address of A, you're going to get back the location of A in memory, which is 8001. Now let's declare a pointer to integer. So we say P is a pointer to integer, integer star P. The minute you declare a pointer, it's going to take up some memory space in here. Let's just assume it's very close to our A variable. So it's going to, for example, be at 8008. And since it's a 32-bit system, it's going to be a 4-byte pointer. And now it's not initialized yet. The minute we say P is equal to address of A, now we're going to assign the location of A to P, meaning that store here the location of A, which is 8001. With this statement here, P becomes initialized and it's now pointing to memory that we can access. This table here shows you what we have so far. We have a variable A of integer type holding the value of 14 in its memory address at 8001. We also have a variable P of type integer pointer holding the value of 8001 at its location, which is 8008. I hope this is not confusing. You have to understand that since we have 2 variables here, then each variable is going to take its own memory, regardless of the type. You can just forget about the type now. You have 2 variables, each one will take up some memory space. That size of the space is determined by the type. If it's an integer, we can look at this table and say, okay, integers take 4 bytes. If it's a pointer, depending on which compilation you use, when you have a pointer, you look at this table and you say, am I compiling my code as 32-bit or as 64-bit? Remember that you have to be on a 64-bit system to be able to run code as 64-bit. So the nice thing about 64-bit operating system is that it can support both 32-bit and 64-bit. But if you're on a 32-bit system, you can still probably compile as 64-bit, but you won't be able to run it as 64-bit. So the recommendation is to always have a 64-bit operating system nowadays. And now you can test your code from Visual Studio. You can compile your code as either 64-bit or as 32-bit. In this example, I'm going to compile my code as 32-bit, so I'm going to assume that P is going to be 4 bytes, and that's what I'm using here. Alright, so now that we know that both of them have memory space, what is inside that memory? What's the data inside? For A, we assign it to be 14. For P, in this statement here, when we say P equals address of A, we assign to P the location of A in memory, which is this location, which is here also on the diagram. So that's its value. Now P itself lives in somewhere in memory to hold that value. You have to store that value somewhere, and that somewhere in this case is going to be 8008. So I hope this is clear so that you understand pointers. Okay, let's continue our discussion on pointers and variables. Again, I'm going to declare an integer A variable, assign to it 14. So this is an initialization declaration. You just immediately declare and initialize the variable. And in this case, it's going to be immediately taking up 4 bytes with 14. And now this is another declaration with initialization. So we declare an integer pointer P, and we assign to it immediately the address of A. This is a better way to declare initialized pointers so that you don't forget and leave it uninitialized. There will be cases that you cannot do it this way. I understand that. We will learn how to do that later on. Or you can initialize it to null, and that way you know that your pointer is not yet pointing to anything of interest to you. So let's move on. Once we say integer pointer B equals address of A, it gets the address of A in here. And when we say contents of P equals 15, so this is new. This is called dereferencing the pointer. So P is a reference to A. Contents of P is a dereference, meaning that the content of P is A. When you say content of P, the content of the memory address at P is going to be equal to 15. So this translates to assign 15 to the contents of this memory address. So this is the memory address, assign 15 here. Once our program executes the statement, what's happening is it's going to put 15 in the address that was pointed to by P, which is the address of A. So this is really just assigning 15 to A. So what I want you to understand here is that P is just the same as the address of A, because P is a pointer and the address of A is what you give to that pointer. Contents of P is the same as A. The contents of P is the value at that memory location, which is the same value of A. It can be used to read or write from A. So this is just a way to dereference the pointer to get to A. And now contents of P equals 15 is the same as A equals 15.